on the top. And I added 2 slides, so you can skip those.
So if anybody wants to go ahead and join us on Discord, that's where we're going to hear any notifications about future meetings.
You can skip that.
And we've already done our project pitches. Did we figure out our game of the semester yet?
That's what it is. So
Our game of the semester is Baltro. What is that? Balatro. Jack, was this your game?
Yeah.
What's it about?
You play poker. Bigger number gets bigger.
It's about poker. Okay. So first we have to discuss the differences between artificial intelligence and machine learning on a definition. Artificial intelligence is an umbrella term and machine learning is underneath it. So artificial intelligence is any technology that has the ability to mimic functions associated with human intelligence, like to see, to talk, to think, or to respond. Some examples of artificial intelligence for seeing would be image recognition. Talking would be those AI voice bots that you see on TikTok. Thinking would be, thinking and responding are both kind of chatbots where you can give them information, they can process it, and then they can give you out a human response. Now, the important part about artificial intelligence is that it does things in a way that a human would do them. That's why it's called artificial human intelligence. Machine learning is specifically a point of artificial intelligence where the machine learns and improves from experiences. So a key point of machine learning is that it is learning without human intervention, and that it is improving its performance over time, and that it is trained on a training set. So some examples of artificial intelligence are predefined rule sets, pathfinding algorithms, or min-max algorithms. Of course, there's a lot more, but these are some 3 major ones. So predefined rule sets is the most simple version of artificial intelligence, where it's kind of an if-then. So in this example, a decision tree could be seen as a form of AI. Like in this, is this person fit? Are they over or under the age of 30? How much do they eat? How much do they exercise? And then fit or unfit. So this could be used for questionnaires, personality quizzes, or even paths in choose your own adventure games. Pathfinding algorithms is when an artificial intelligence is able to find any point from one point to another point. This is like the traveling salesman problem. This is very important for pathfinding algorithms in video games, but you can also apply it to different concepts of finding things that are similar to one another, like a Google search. Instead of saying we're 4 units away from each of these objects, you could say that A is most related to apple, or it's most related to ant. And then what the artificial intelligence will do is it'll say, if I want to get to this point, what is the fastest way? This way is 14. This way is, I think, 7. And it'll choose the fastest path. A min-max algorithm is what we use for artificial intelligence that's going to be playing games against us. So min-max algorithm evaluates all of the possibilities and adds them up based on a score. And in the computer science world, we call this a heuristic. And depending on how high the score is, it'll choose the action that gives it the highest score. So for a tic-tac-toe, if the artificial intelligence only had this spot open and it was playing X's, it would analyze which spot gives me the highest point score and take an action accordingly. In terms of machine learning, this is where things get a lot more complicated because the machine learning is learning. So instead of mimicking human behavior, it's mimicking human thinking. It's basically creating a computer version of a brain. And so the main ones for that I put down are neural networks, evolutionary algorithms, and Bayesian networks. So neural networks are the most common form of machine learning, and they're what are used in most everyday processes. Neural networks recreate brain neurons, which is why they're called neural. In neural networks, you have a front layer, a back layer, and any amount of layers in between. The front layer is called the input layer, where the data that's fed into the machine goes. Then it does all of its processes in between, and in the end, it spits out what it wants. So each of these nodes represents one neuron, meaning that they are thinking about one thing. So the more complicated algorithms can have hundreds of neurons. They can get really, really big. Evolutionary algorithms are not used as often because they take a lot longer to run than neural networks. Evolutionary algorithms, we say, let's start with 100 problems and have those problems come to a solution. Then we're going to evaluate those solutions based off of our score, which earlier we said in computer science terms, the score is called a heuristic. So we say, how well did these solutions perform? And then we'll take like the top 50 of them and have them reproduce by essentially taking half of one problem and half of the other and sticking them together and seeing if the solution pops out better. So evolutionary algorithms are mimicking survival of the fittest and Darwin evolutionary genetics. And then finally, Bayesian networks are the original form of machine learning that have been pretty much outdated these days. Bayesian networks involve creating a graph of related objects and then using that graph to come to conclusions. So imagine we have a two-dimensional graph. We have our X plane and our Y plane. And we say to the algorithm, I want you to put a point on this graph. And it does. And we say, that's a good job, but the point was actually 2 spots over. The machine will go, okay, I'm going to keep that in mind. And then we'll do it again, put a point on the graph. This time it'll put it 2 spots over because it learned from the previous generation. So Bayesian network, and a lot of these rely on graph theory to come to conclusions and improve learning. So some examples of artificial intelligence in video games. Artificial intelligence is the backbone of video games because when it comes down to it, artificial intelligence is basically any program that does something where it has to think. So the most common example of artificial intelligence are NPCs. Any form of NPC that you interact with is running off of an artificial intelligence algorithm. And pathfinding algorithms. All pathfinders, they have to figure out a way from point A to point B that requires thinking and is therefore artificial intelligence. Now, here's an example of artificial intelligence in video games. This is probably the most popular example. This game was made kind of to prove how interesting artificial intelligence could look like in a video game. And it's kind of like an early version of a chatbot. The reason why this is different from machine learning is because it can't come up with any of its own ideas. The programmers made each line and they said, if the user thinks this way, reply this way. And you'll see in the video that if the user does something out of the box that the programmers didn't design it for, it just doesn't know how to respond. How many of you know about facade?
Nick! Hey, I thought I heard someone out here. Great to see you. It's been a while. How's it going? Oh, come on in. I'll look at this.
Okay, so for those who don't know, Facade is a video game, I think that came out in like, what, 2010? And the point of the game is that 2 characters, John and Grace, are in the middle of a divorce, and then you, the character, are speaking to them and talking them through the divorce. But if you kind of just say random things, it doesn't know how to handle it and kind of breaks. Now, machine learning in games is relatively new, and machine learning as a concept, it has been around for a very long time, but it's had a boom recently because there was a huge technological development in about 2012. So prior to 2012, machine learning wasn't seen as a viable path in computer science, and that wasn't until something called AlexNet was discovered. And AlexNet basically made it so that machine learning could be run by people who didn't have supercomputers inside of a professor's basement, and that it wouldn't run for like 3 days. And that's why machine learning, that's why we're having such an AI chatbot boom right now. And it hasn't really made its way to video games yet. But I'm sure you guys have all seen the videos of the Super Mario robot trying to figure out how to play the video game, where they're pretty interesting. It's like a time-lapse video where they give a machine learning algorithm. They say, They just throw it in the world and they give it the score, the heuristic of get to the end as fast as you can. And over the course of the time lapse, it figures out how to move left and right, then it figures out how to jump, then it figures out it needs to avoid enemies, and slowly gets faster until it can run it relatively at a fast pace without dying, but it's never perfect. Machine learning also in video games is great for RNG and realistic terrain generation, but I haven't really seen it used to its fullest potential. Now, what I think is a very popular example of machine learning in games right now, this game is more of a gimmick, but I feel like it's a spiritual successor to Facade. In this game, you're playing as a little vampire dude, and you're trying to convince NPCs to let you inside, and the NPCs are controlled by machine learning chatbots.
Oh no, we got 2 stars basically. All right, so that's gonna be the excuse, y'all. That's gonna be my main excuse, my go-to excuse from now on until we get 31 houses, okay? What in the name of my back pain are you doing knocking on my door this ungodly hour? What do you want, flower child? Hey, Mr. Boomer, someone next door ordered DoorDash to your house. Oh, I suppose that my neighbor, not a neighborly of them. If they're treating me, I guess I can tolerate the flower child invasion for a little bit longer. Just make sure they don't leave any of that weird smelling incense behind. No problem, here's your food. Well, I'll be danged. I didn't expect a hippie like you to actually deliver some decent food. Come in and let's enjoy the strange ideas and convert. He didn't even give me a thumbs up. But you know, I don't care. I don't need that thumbs up. Yeah. Yeah.
So in this game, you can say whatever you want to the chatbot, and it will come up with a unique response that actually makes sense. In Facade, if you just say hamburger, he goes, that was awkward. But in this one, they'll be like, oh, I would like a hamburger.
Pretty reasonable.
Oh no, we got 2 stars.
So now I'm going to talk more about the technical side of artificial intelligence and machine learning and some of the problems with it. So one of the major problems with artificial intelligence is that the parameters have to be decided by humans. Unlike machine learning, it can't really come up with its own ideas. And we see that example in Facade where we're basically using giant decision trees or if-then statements to decide how the artificial intelligence is going to respond. And it can't really respond. Well, it can respond in unpredictable ways, but it can't come to unpredictable solutions. So the other problem with it is that because of that, it's brittle. And what I mean is it only works for what it's made for. It can't really be applied to more than that. And another big problem with it is it must be robust if you want it to work properly. So that's going to require a lot of resources and a lot of maintenance by programmers. And some of the problems with machine learning, though, is explainability. Machine learning kind of operates on a black box principle, meaning we don't actually know how it works. We're just assuming that it's working for the right reasons. It also requires a huge data set because it needs to learn, and it can only learn based off of what you give it. If you give it too little information, it's going to come to some interesting conclusions or be skewed in different ways. And that's why machine learning can have bias. If you give it information, like if you were trying to make a dog detection, but your training set had an overwhelming amount of huskies in it, then it's going to be biased towards identifying huskies or identifying larger dog breeds. Machine learning also has, I'm just going to say it, a really difficult learning curve. It's very, very annoying to make a machine learning compared to an artificial intelligence algorithm. So I'm going to go into more in depth of the problems with machine learning because those are the more pressing ones in the modern day. So the huge one is explainability. That's actually a subject of research, and you can take a class at Auburn called Explainable AI. I know because I dropped it. So for example, here's a machine learning algorithm that was made to tell the difference between a husky and a wolf. They look pretty similar, but the model is about 90% accurate. It can correctly identify wolves versus huskies. Then the explainable AI people got it, and they ran it through their own algorithm, which forces the machine to give its reasoning. The reason why it was so good at telling the husky and wolves apart was because it was actually just detecting if there was snow in the background. If there was snow behind it, it's probably a wolf. but if it's inside, it's probably a dog. So we didn't make a husky versus dog, we just made a snow detector. The other huge problem with it is that it does require a large data set. And so if we don't have that large data set, what are we gonna do? There are two major ways to split up our data for learning. The most common way is just called the test train split, where we usually do 70% for training and 30% for testing? Yeah. And what that means is for the training data, the machine is running through and it's learning all of this information. And then we test it and we say, now that you've learned everything, tell me, is this a dog or a wolf? And it'll say so, and then at the end we give it a grade based off of our testing set. Now the main benefit of using the test train split is that it is simple and fast. The problem is that it only works on large data sets, and it'll fail if data in the testing set is not seen in the training set. So if your testing set, because usually it's randomly scrambled, but if your testing set was to identify dog breeds, and then in your training set, you only had like Chihuahuas, Shih Tzus, and give me a dog breed.
Border collies.
Border collies. But then in your testing set, there was a mountain dog, like a Bernese mountain dog. They would have no idea what that was because they never saw it before. The other method, and this is more commonly used for small data sets, is called K-fold cross-validation. And so what this one does is we're splitting our data into K folds, and K is just a number that we come up with. So maybe we'll split it into 4. We determine the number based off of a lot of graph theory. So after we split it up, every set takes a turn being the training or being the testing. That way, all of the data has a chance to be trained on, and all of the data has a chance to be tested on. So because of this, this set is going to be a lot more robust, and it's not going to be as prone to failure. And it's great for small data sets where you can't afford to have 20% of the data never be seen. The major problem with it is that it takes a lot longer, because in this one, we're only running it once, but this, we're running it 5 times. So it can grow exponentially large. I ran out of time to make the presentation, but in general, the major difference between artificial intelligence and machine learning is in the name. Machine learning learns, and in order to learn, it has to be given information. Whereas artificial intelligence, believe it or not, can actually be as basic as an if-then statement. And so I encourage all of you to try using artificial intelligence in your game. And if you are especially feeling cool, try out putting in some machine learning too. Yes.
Was the AI certification worth it?
Every time I go to the career fair, they ask me if I want to do data mining for them.
Great.
Yes.
Can you actually create a neural network?
How do you create one?
Yeah.
Okay, so it's a pretty complicated process. There are multiple methods of neural networks. This is going to take a while. So in order to train the data, we have to choose a graph theory, and there are several ones. There's linear graph theory, where our output is either 0 or 1. And then there's sigmoid graph theory, where our output is between 0 and 1. And then there's ReLU graph theory, where our output is between negative infinity and positive infinity. So you would use linear if you were just trying to make like a positive or negative, like a diagnosis. And then you would use sigmoid if you want to keep your results on a scale of like percentile. And then ReLU if you just want it to be able to do whatever it wants. Afterwards, you have to run the training, which is run through a thing called backpropagation, which is very complicated, and it spits out your answer. But the way that it determines the answer, if you're curious, how does the machine actually figure out which one's the right answer? Well, it will run this training data, and then all of the results, it'll put on a scale of 0 to 10 or 0 to blank of how likely it thinks which result is. And then it'll pick the highest result and tell you this must be it because it has the most points in its favor. Yes,
Is the AI cert through Auburn or is that like a separate thing?
it's through Auburn. So computer science students have to take in major electives. And you can just take whatever computer science electives you want, or they have two certificates, the cybersecurity certificate and the artificial intelligence certificate, where for your electives, you will take classes in those categories.
Okay, thank you.
All right, anyone else? Okay, thank you for listening.
Oh yeah, we changed the schedule slightly. We just kind of swapped these two. So now Unity tutorials next week. I'll be giving that if you're interested in learning it. Next week after that is the game jam. And then first project updates will be on the 3rd March. Yeah. Also, t-shirt design. We've had one submission so far. If you want to have a chance for your idea to be on our official merch, you should submit a design. It's just a back design. The front will just say TigerDev in the year. And you should buy merch. Yeah, that's it. Y'all can leave now.